Alrighty, good night everyone, and welcome to the latest episode of the Great Heathen Arena. And today we're going to be having a debate on the shape of the Earth. Let me introduce to you briefly our debaters for today. Arguing for the round Earth or spherical spheroid Earth position is Gary S. And arguing for the flat Earth position tonight is Shawn. Shawn G. Alrighty, Gary, you're good to go. Let me know when you're ready.
Okay, I'm ready. Yeah, today I'm just going to be pretty much pointing out observations that we see every day in the natural world and show how that's consistent with the Earth being spherical or a globe or having a curve to it. There's certain observations we see every day that's consistent with scientific theories that confirm that the Earth is a spheroid and not a flat or stationary plane as it's claimed by flat earthers and geocentrists. Um, Certain observations you can see, such as the sun going across the sky and maintaining the same angular size as it goes across the sky. Also, other observations would be boats going over the horizons. Also, the sunset. We also see that go over the horizon, even though it claims that that is simply perspective or atmospheric interference. It's inconsistent because um, perspective only speaks to what you see. It doesn't actually speak to what you don't see. So to make a claim that perspective explains why you see half of an object is just inconsistent with what we currently see in the natural world. Also, um, um, the spherical Earth is also consistent with what we see with gravitational pulls and also certain gravitation arguments that are put against the Earth being any other additional shape. There are several experiments you can do, like the SIP-on experiment. There are experiments done by Cavendish, which have been reproduced multiple times. Also, there's other experiments you can do to confirm that gravity is a force and that it actually works. Um, One reason we know it works is because equations are used for multiple things and they seem to hold consistently that objects fall at the same rate. We can confirm that with experiments such as the bowling ball and the feather, and that experiment has also been recreated multiple times by not just professionals but amateurs. It's inconsistent with any other um, any other explanation to why objects fall towards the Earth and not away or across the Earth. Another observation that we see is dealing with the sun and the fact that we see things like the midnight sun. There's no explanation on any other model how you would get a 24-hour sun in any other period, um, in any other model other than a globe model. I haven't seen any explanation of how you get a 24-hour sun for just one day on any other model other than the globe model. That's one thing that would have to be explained. That any other model would have to explain how that would work on their model. I haven't seen any explanation of how they can have a 24-hour sun at any point in time. Also, other models seem to have problems explaining how they stay in line with other laws like thermodynamic laws and other laws. They also deny the existence of multiple things such as space, planets, um, satellites, which we all know work. They make claims that just don't add up. For instance, regular radios, you can easily go under underpass and they continue to work. But satellite radio, if you go under underpass, they stop. They must show how that's inconsistent with the Earth being a globe, because it doesn't make sense for a radio to stop if you go under an underpass, but uh, regular analog radios work no matter if you're going under underpass or not. That shows that the signal is coming from above and not from a radio tower on the ground. I mean, there's multiple examples that we see in the natural world that point to the Earth being spheroid, not a flat plane. I mean, I guess that would be it for my opening presentation. See, see what Shawn has as a rebuttal for those particular topics that I brought up.
Alrighty. Thank you, Gary, for your opening statements. By the way, if you're gonna check out these two debaters, the links to their YouTube channels are in the description below. Anyway, okay, Shawn, whenever you're ready, it's your turn now.
All right, thank you for having me. I'm ready to go.
Okay.
Basically, it's pretty simple. The things that he touched on were a lot of observations. No one walks around every day observing any kind of curve. NASA and themselves have told us everything from 70,000 to 130,000 feet to see this curve, yet there is no curve until you actually get to about 130,000 feet, which is the only time they've ever said it consistently. Their shape has changed numerous amount of times to the point where we should be able to physically feel the amount of times that their globe has gone from a ball to a pear to oblique to every other sign or shape that they will continue to tell us. He touched on a lot of things like observing laws that certain laws that they want to say are, and a lot of people can't even do these. So it's pretty much the majority of people just taking it for whatever they say, which is it's not something I can just go by. As to satellites and cell phone towers, we do not all have the same points of views. I do actually believe we can go to out the inner orbit of space, and regardless, with weather balloons would be able to do the exact same thing, especially if it was tens of thousands of satellites out there like NASA claims. What else is there? Basically, gravity is not proven. It's a theory. It has been explained 1,000 times that it's a theory, which is why there are so many companies trying to prove it so it can become the standard law. The tests that they have shown have not proven it. Otherwise, it would obviously been proven and still not a theory. There are also numerous tests disproving gravity and showing that it's not exactly how they say it is. When it comes to the oceans and boats going over or away, both another observation that only a human can see and give for themselves, yet the only issue no one ever talks about is the fact that the ocean is constantly moving, swaying, so therefore to tell me a boat is going over a curve is impossible for anyone to observe themselves. As for the sun, numerous pictures, you can go to any website and hit images, and you will see obviously that the sun does change the shape. It does become bigger and smaller as day projects and ends. A lot of their ideas of how space works is all theory. To know a star is a million light years away is speculation. Therefore, they cannot tell you exactly. And I believe that majority of what NASA and the government and these scientists tell you is speculations, not proven science, yet people take it for it. As far as it being a ball and totals in this speech, no one here has ever seen a curve or had the opportunity to prove that it is a curve. Therefore, how do you think no, it is a curve? how do you know it is shaped as an oblique, ball, or pear, whatever you guys go off of these days. And that's about it for now.
Alrighty. Thank you, Shawn. Okay, so now we're going to be moving to the rebuttal period of this debate. Gary, you're up.
Okay. During my presentation, I didn't mention anything about NASA. I hate that he used like half of his presentation time to speak of NASA because I didn't mention NASA. But um, their observations would also be valid. I understand he simply wants to ignore all the photos and everything else. That's fine. That's why I didn't mention them because I knew he wouldn't accept that as evidence. Another thing, he mentioned that there have been numerous tests to disprove gravity, but didn't mention one of them. I mentioned at least two of them that prove gravity, and he didn't address either one of those. Maybe he's not unfamiliar with those experiments. One of them he can do himself, but I'm pretty sure he hasn't done that experiment to confirm that that is gravity. Two, um, he mentioned boats going over the horizon and sunset. Those are two things that we consistently see, and there are two observations that we consistently see that confirm that these things are going behind an object, and the only object that they can be going behind of would be the Earth. Also confirming that the Earth is a spheroid and not flat, unless he's suggesting that the objects go beyond the flat plate, which I don't think he's making that claim. Um, so they would be going behind the horizon. Also, we know that for a fact because, of course, the boats aren't going over the edge. Boats are obviously sailing across the sea, but we also see them go underneath the horizon, just like we see the sun go underneath the horizon. Um, there were other points he didn't address, such as thermodynamics. I'm not sure if he's familiar with what those are, so maybe he doesn't know that some of the flat Earth claims um, deflect those. He touched on saying that there are objects obviously floating in what we would call orbits, but he considers them inside of his dome, which is again problematic for thermodynamics, so he'd have to explain that. Um, I mean, he touched on only a few of the things that I said, but he didn't provide any evidence for those. So I would like, hopefully, in his rebuttals, he presents evidence. I also, maybe less NASA since I didn't bring up NASA as part of my evidence.
What? What's with the mic? Okay. Alrighty. I guess Gary's done with his rebuttal. Okay, so now we're moving back to Shawn again.
Yes. All right. Thank you, sir. I was actually giving you the benefit of the doubt on that, so I'll go ahead and touch on the things you would like me to. As for photos of your guys' globe, not one is actual real untouched raw photos. They are all CGI, and I touched on NASA because NASA is where you have obviously gotten all your information, seeing how you do not own a space shuttle. As for tests proving whether gravity is real or not, you can do a simple test by putting oil and water into a jar. Water will go to the bottom. Your gravity states that gravity is what makes is the reason why a heavier mass will fall faster than will fall underneath it, but it doesn't. If you actually do the test yourself, you will see that oil, which is a heavier mass, will float on the water. As for boats going over a horizon, that is not true. It is distance, and other than that, you will not be able to even tell where your horizon is because there are swells and waves that would obviously give your observation a false truth. As far as a curve, you do not see one when you're looking at a horizon. The best example is at a beach. You may see swells, you may see waves, but you do not see a curve. We can do simple tests, as in doing surveying, I can do a mead line as far as I want, and still there will be no curve when I do my measurements and incrementation in different increments. As for satellites and space, like I said, you guys may have to stay stuck to a certain idea of what your globe is. As a flat earther, I do not. I do not believe there is a dome. I believe the dome is a theoretical idea of what is really there. As for what it is, in my opinion, it is our atmosphere, and the gap between our atmosphere and space is what most reference to the dome. I do not believe it is a actual hard surface that cannot be penetrated or gone through. And as for any other situation that goes along with me bringing up NASA, I like to state that if your information is not, or if your information is not from NASA, I would hope that you have been there or been able to prove this with your own eyes. Most of the things that he will say or have said isn't anything he's done himself. It is all things he's been told, and couldn't prove on the spot because he's told these things, so therefore he repeats them. A lot of the things almost everything I've done is all research and what I consider provable at any time. I'm good for right now. Let's see what he has to do.
Okay. Alrighty, I'll give another shout out to Shawn and Gary, and now we're gonna move on to the cross examination, aka Q&A session, where our debaters get to ask each other questions. And Gary, you get to go first. You get to ask questions to Shawn.
Okay, Shawn. Let's see. Let's start with the first question. If the Earth isn't a globe, how do you explain a midnight sun or a 24-hour sun?
By the seasons, the sun does move off to a Cancer and a Capricorn line, as you believe in your model, and it does it the exact same way. There is almost zero proof, or maybe any raw footage or data that shows that it actually happens on your south pole. Therefore, I would like to ask, when they say they have that, where is that?
Is that your question that you were asking me?
No, that's part of my answer.
Okay. Well, first of all, we know it happens in the northern and the south pole. Let me focus the question more. Since we know that there's a 24-hour sun in the northern hemisphere, and it's dark other places that are clear on the other side of the globe, it would be dark, but the sun is completely up. Well, actually, let's say on the same side, like in California, it's completely dark, but the sun is still up in Alaska. How does that work if the Earth isn't a globe? It can't work the same way.
Okay, it would actually only work on a flat map or a flat Earth, basically because as the globe is a ball, and for it to happen that way, it would have to go past your 23-degree tilt. On a flat, it works perfectly because we do, like I said, have a Cancer and a Capricorn line that the sun does shift to through the seasons. When it obviously is on the Cancer line, it does it shines the exact same way. It still hits Alaska. It still does in the far northern hemisphere. I don't see how you would think it doesn't, but it does work the exact same way. It actually makes sense on a flat map.
On your model, you're not using a spotlighting sun?
No.
So the sun doesn't spotlight. So why can't you see the sunlight from California then?
Because your eyes cannot see that far.
You can't see. I mean, it's right. Alaska is right above you. I mean,
Can
you
you
can't.
see Alaska from? I can't see Alaska from my house.
Well, I don't know where you
I
live,
can't give.
but if you're in
I'm in San
Seattle,
Diego.
okay, yeah, where you're completely at the bottom. But say you were in Seattle, it'll be completely dark in Seattle, and you would still be able to see the sun in Alaska, but you can't, right?
No, you can't. The sun does. I mean, you're making it seem like the sun would be a spotlight that doesn't move. The still it still has a revolution. It still goes around. There's a certain point where the sun's so far away from where I am that, or Seattle is, that you don't see that far. It may be a haze over the sunset, over the horizon, but you don't. It's still a distance of perception. That would be almost like saying when it's dark in New York, you should still be able to see the sun in California, but it doesn't work that way.
But
The
actually,
sun is
you can see the sun from California when and see it from New York. You can't do that. You do
when
understand that, right?
not when it's dark in New York. You can't.
No,
All
not
right.
when it's dark.
Shawn, you can you can go ahead and ask Gary some questions now.
Yes. All right, Gary. You constantly state that gravity is something proven. I would like you to explain to me where it is proven and how you have tested this yourself. Have you done these tests yourself?
Well, one experiment what I would tell you to try is the SIPON experiment. That's an experiment that most people haven't mentioned, but it shows how you can actually get water to run uphill using only gravity power, and also the Cavendish experiments, which have been retested multiple times. Um, those, I mean, just those two there should help you. I mean, anybody can do a sip-on experiment. It's extremely easy. All you do is take 2 bottles of water and a straw. You took the straw in the bottle at the top and run it to the one at the bottom, and the water will be sucked from out of the container down into the lower container underneath. That's gravity pulling the water actually uphill. Are you familiar with that experiment?
Shawn, are you there?
I'm here. My bad. I don't know why my thing went off. Yes.
Yeah, are you familiar with the sip?
Yes.
Are you familiar with a sip-on experiment?
Yes. As far as I can tell, that is more of the vacuuming of the air displacing itself, not of gravity.
Yeah, but a sip-on experiment works in a vacuum. It's been tested into a vacuum and it works the same.
So you're saying that the vacuum is like a vacuum cleaner is gravity too? Is this the same effect?
No, not a vacuum cleaner in zero
No, no,
atmosphere.
no.
They suck all the air out.
I understand it's not a vacuum cleaner, but I'm saying how is the vacuuming effect? How's the vacuuming effect proven as gravity?
What do you
Or
mean
how does that?
vacuum? There's no air. They put it into a vacuum and they suck all the air out, so there's no atmospheric pressure to affect the water, and the water
Okay.
still is sucked up and down.
Okay. Have you done this test yourself?
Yes. Well, not in a vacuum, but I've done it, of course, where the water just sucks out of the thing. You can easily siphon water that way.
So you haven't done the test you're explaining.
Yes, I just told you I did. I haven't done it in a vacuum. I don't have a vacuum chamber, but I know that
Okay.
the experiment has been done in a vacuum, which
Okay.
proves that
So
it's
what you're
affected
stating.
by air power or atmospheric pressure.
So what you're stating is that the test you have done is not the test that you are telling me about.
No, I have done the test. I have not done the
Okay.
test in
Okay.
a vac. I have not done the
Okay.
test in a vacuum. I don't own a vacuum chamber.
Okay. So then it's not the test you're explaining that proves it. So you
Wait,
haven't
wait.
done the test yourself.
No, I've done
I'm
the test.
I'm trying
I
to.
have not done it in a vacuum. I do not own a vacuum chamber.
Okay.
I've seen
Thank
it
you.
done. I've
Okay.
seen it done in a vacuum.
On TV. Okay. For my
Wait a
next
minute.
question, what? Yes,
Well, what does that have to do with anything? The experiment still works.
because what I'm trying to
It works.
explain is that everything that I'm going to explain is stuff I can test for myself, and anybody can test for themselves and actually do it.
Yes,
You
you
stated,
can do
hang on, Gary,
can do the
hang on,
experiment.
Gary.
Yeah,
You stated,
no interruptions, please.
you stated that there are a couple tests that anybody can do to prove gravity, and you stated these, what in my impression, that you have done these tests like you said everyone can do, but you haven't done them, which is, goes to right back what I was saying, that everything you guys are going to say is things you have not done yourself, but you're just listening and repeating.
No, I have done a Cipron experiment. It's easy. They do it in elementary school. But that's what I'm telling you. That experiment has been done. You have made the claim that it's due to atmospheric pressure. Can you
Yes.
prove it? If you haven't, have you done the experiment?
No, I've not done that experiment,
So
but I
you do,
can.
so you do, so you cannot say it's atmospheric pressure, can you?
No, I didn't state that the reason that I've done that test and that this is why it is not gravity. I was asking you if that proves it. I don't think gravity is real, so why would I have done a test to prove it is, if it is real or not? I
To
know why things
confirm
are the
whether.
way they are.
How,
But
how would you know that? What experiment have you done to confirm that the Cipron test isn't gravity powered?
well, here's a kicker to it. I don't have to do any tests that prove or disprove gravity because your scientists still can't prove it.
I'm telling you, this is a gravity experiment that you can do to confirm gravity, and you said you
Okay,
haven't
so
experienced your test.
okay, you can't prove gravity if they can. And if you're telling me you've proven gravity, you should probably go call somebody and then you can be a millionaire. Because if people with
I'm
millions
doing
of
the
dollars,
same experiment they've done.
okay, that obviously does not prove gravity.
Why
If
would
it
it?
proved gravity,
It's
then we
it's
wouldn't be
gravity
having this
powered.
discussion.
No, it's gravity
Gary,
powered.
please, please don't talk over Shawn while he's trying to make a point.
Right, but
It,
Sean is
go
denying
ahead.
the fact that it's a gravity powered test. It's shown
It's,
that it runs by gravity. He's just saying that it doesn't, but he hasn't done the test himself.
okay, I would like you to say the theoretical gravity then,
It's not.
because it is not proven. It is not. If it was proven, we would not be having this discussion. It's
Just
not proven.
what force is pulling the water out of the container?
Atmospheric pressure and mass. I don't know
Atmosphere.
for sure. I'm not 1,000% sure, but you asked me what I believe, so I am telling you what I believe.
But you haven't done the experiment to confirm that's what it is.
Nope, I have not.
Have you seen anyone do the experiment to confirm what it
No, no, I haven't.
is? So what are you basing your observation on?
Scientists not even being able to prove its gravity.
No, not what scientists are saying gravity is doing it. What have you done to prove that what you just said causes the water to come out of the canister into the lower canister? What experiments have you or anyone else done to confirm what you said is the reason why?
Because I know there is mass, I know there is atmospheric pressure, and I know there is density. Therefore, it has to be those, because those are proven.
So you're using the law of Archimedes?
I'm using the law of everything that is proven. That's what I go off of. I'm not going to go off of anything. I'm not going to tell you that something is a fact and something is proven if it's not.
Well, you brought up density and mass would be the law of Archimedes, but you understand that requires a downward force.
Okay, atmospheric pressure does that as well.
Right, but you haven't
And
done any experiments to confirm that atmospheric pressure is affecting the canister at all.
yeah, I have a barometer. I can test atmospheric pressure. I can
No,
tell you out right now what our
you can
atmospheric
test,
pressure is outside.
right, right. You can confirm that there's an atmospheric pressure outside, but is that atmospheric pressure
Well, it's
affecting the
everywhere.
canister? Is it
It
affecting the water in the canister to make it go to the bottom?
atmospheric pressure is everywhere. Therefore,
Right.
yes.
No, the question is, what test did you do to confirm that atmospheric pressure is affecting the canister, causing the water to go uphill?
You're now it's just semantics because I told you I didn't do the test. Therefore, how are you asking me to tell you how I can prove atmospheric pressure is the reason for it? I can
Because
tell you how.
you're making the claim that it is.
Okay, I'm not making the claim it is. I'm making the claim that there is no such thing as gravity. Therefore, it must be.
Right. I'm telling you that they've done an experiment to confirm that
Okay.
atmospheric pressure has, they've done a test to confirm that atmospheric
Mhm.
pressure has no effect on the water coming out of the canister going to the lower canister by putting it, encasing it into a vacuum chamber. You have done no
Was
experiment at all to show that atmospheric pressure has any effect on the canister at all.
okay. So did they do the test to prove gravity or to prove that atmospheric pressure wasn't the reason?
They did that to confirm that atmospheric pressure wasn't the reason.
So which one was it? Gravity or atmospheric pressure they were doing the test for?
They were doing the pressure to confirm that gravity was affecting the canister, pulling the water uphill from the higher canister to the lower canister, and that atmospheric pressure didn't play a role, and it didn't. But you haven't done any test to confirm that it did. Not a one.
Oh, you're 100% right. I have not done any test to prove that that certain test that they did for gravity has anything to do with atmospheric pressure. So I guess we'll call it
No,
an anomaly.
well, no, you haven't done any test to confirm that the claim that you have made that atmospheric pressure is the reason why the water comes out of the canister into the lower canister. You can't.
You're
That's just a
100%
claim.
right.
That's just a claim that you can't substantiate.
You're 100% right. I did state that I had not done the test, yet you keep wanting me to answer a question that obviously can't be answered, seeing how I have not done the test.
No, I'm just confirming that your claim that atmospheric pressure is causing the water to move is something that you can't substantiate.
Okay, then I will say that the reason it happens is magic. Does that make you happy?
I mean, if magic is fine for you, I guess, but for me, that's insufficient reason to believe that atmospheric pressure can cause the water to leave the top canister, go uphill, and go to the lower canister.
Can you tell me again what does make it happen?
But apparently, gravity does.
Theoretic gravity, you mean?
No, not theoretically, because we can see it and we can measure it.
No, you can't, because if that
We,
was the
we
case,
can't measure
it'd
it.
be a test you'd be able to do over and over and repeatable, and it would be proven. It is not proven; it's still a theory.
I just gave you a test.
I
I just
understand that,
told
but
you you can do the sip-on experiment, which is simply done with two canisters of water and a straw or a hose.
okay. So you're telling me that gravity has been proven now because of
Yes,
that
it's been
one test.
demonstrated. It's been demonstrated. No, not just because that one test. That's one test that you can do. You can do the Cavendish experiment. I don't think you have the equipment, which I mean, you can try to do it, but you can do the Cavendish
So,
experiment. And also you can measure the rate of gravity as it falls. You could
so
also,
what
if
you're
you want, you can buy you a vacuum chamber and confirm that objects fall at the same rate.
okay. So what you're telling me is gravity has been proven.
Yes, demonstrated, measured.
Are you sure about this? Because I can tell you
Yes.
right now. Okay, gravity hasn't been proven, Gary. Can you show me where they say, "Hey guys, we figured it all out. Gravity has been proven.
No.
No more of this theory stuff."
Well, first of all, it's a scientific theory and it's based upon fact. They didn't say they knew it all, but what we do know is contained within that scientific theory.
It's still a theory. You're stating it as
No,
if it's been proven.
it's a scientific
Um,
theory. I notice you keep leaving the scientific part off, so you can claim it's just a simple guess,
It's
as in
not.
a general theory, but it is a scientific theory.
I'm going to
Okay.
interject really quickly here. Shawn, are you aware of what the definition of a scientific theory is? Or, what is a theory in science?
Well, a rough draft of it, but I do know that it hasn't been proven. It's not. It's not law yet. It's not a scientific law or a scientific fact. I'm sorry.
Theories don't become facts or laws. The theory
What?
is the highest you can
No.
reach in science.
No, it's not.
Okay.
We just went through this.
Okay, so, basically, in science, a theory is a model or explanatory framework that, does enjoy, empirical support or, empirical slash inductive support, and, has been quote unquote proven. But, science isn't really in the business of proof. proof is a feature of deductive discipline, which science is not. But for all, I guess in layman's term, you can say that a theory, is a scientific model that has been, proven. If we're using layman definitions, but yeah, I mean,
Well, as far as I know, and everything that's explained through scientists and everything, they're still trying to prove it. That's why they're still doing tests. It's not something that is concrete. It's not they haven't said, "Hey, we figured out it's definitely gravity." It hasn't been done
So
yet.
so the
They can do it.
the equation for gravity doesn't work.
It's obviously not every single time. Obviously, not enough sufficient amount of times for them to be happy with it, if so to say.
Now I'm pretty sure it works every single time.
yeah. Okay. So, Gary, what is this equation for gravity that you're talking about right now?
It's mass times acceleration, right? No, it's mass. After,
Yeah. Okay. Yeah, that's one of them. There's another one that
I
goes like
would
this. The force of gravity is equal to the, capital G, which is the gravitational constant, times, the mass, the mass of, multiplied by the mass of both objects you're comparing. They usually label it as m1 times m2 over the radius squared, if I remember correctly.
oh yeah, your math is strong.
Yeah. Yeah. Here, I can look it up right now. Um, okay. Sorry. I meant to say distance squared. My bad. But yeah. So okay. So I had it right. F equals m1 times n2 over the distance squared. Yeah, that was like the main equation of gravity developed by Newton.
Right.
So
And
Shawn, you're saying that we have found examples where this doesn't hold
say it
up?
again. You were kind of breaking up.
Um,
I,
Wait, can you guys hear me now?
I can hear you. It was just a small breakup right when you were talking at the time.
Okay. So this equation that I just mentioned, we have. You're saying that we have found, or scientists have found examples of, it not holding up, or cases where it doesn't hold up.
Yes. The reasons they still can't explain to give it the backing that I guess you would say it needs.
can you give an
I mean,
example of a time where the equation for gravity didn't hold up?
for equations, no.
Can you give an example of where? I mean, that's what I'm understanding. That equation, as far as I know, holds. Uh, so, is there any example you can give where it doesn't hold? I mean,
Off the
like,
top of my head, no. I just know that as far as I'm concerned, it's my merit isn't to do that. If they're telling me that it's not, they're still doing tests and they still need to do things to make it proof.
well, I mean, you are correct about one thing. The theory of gravity is not complete. We don't know everything about gravity, but anything that we would learn would simply become part of the theory.
It
But
can
since we
become
don't
part
know,
of it, but they're still. Go ahead. I'm sorry.
yeah, the theory is it's always being built, and it will only improve. Our knowledge of it will only improve. If we found something out that we thought to be true, we would update the theory, but it would never be thrown out. It won't be overthrown. Like some people seem to think that a theory is supposed to graduate into like a fact or something. That'll never happen. It never does. It stays the theory. The theory only becomes improved upon. Like the the germ theory of disease. It will never stop being a theory. It will only add and expand our knowledge of what we know of germs.
Even though we have directly observed, these microbes, these germs themselves, and these germs causing diseases, yeah, it's still a theory. But anyway, I have a question
But
for both of
I'm
you.
sorry. Okay, go ahead. I'm sorry.
Gary, Shawn, what would convince you to adopt the opposing view, or what would cause you to change your mind?
You asked me for falsification. I've mentioned this numerous times to flat earthers. What would falsify the globe Earth for me is seeing the angular size of the sun change during the day with like a sun filter, to actually get the actual measurement of the sun. If they could show that happening during the day, that would obviously bring a crack in what I know of gravity. If they could show any pictures of the edge, that would do it. Any any evidence that Antarctica is actually spread out the entire length of the entire planet, that would do it. Now, if they could show me, if they could just show me that objects don't fall at the same rate, that would do it.
Okay. What about you, Shawn? Do you have is there anything that would change your mind, or
Yeah, of course. They would first have to show me gravity. There's not something that can be shown. Uh, there's no accurate measurement for it. He's saying that there is, but there's not. It's it's no way to prove that it is doing what it's doing because of gravity. Gravity is just a term. It's a wonderful idea, basically. If they could show me different things that have failed that way, why they failed, then could probably maybe convinced. But as far as being convinced, it's that there's too many holes in it. There's way too many things that can't be explained, and there's basically they would have to explain all the holes that are there and fill those gaps in. Explain to me why that all these planets aren't being sucked into the sun, considering the mass of the sun. Basically explain exactly why and then show me. I would like to see a system for testing this gravity, not just an equation.
okay? And out of curiosity, Shawn, do you do you believe that this flat Earth? Do you believe it's a disc or a square, or
I would say
have you made up your mind?
it'd be more of a disc.
Okay. Okay, I'm asked that because I'm genuinely curious. I'm new to this flat Earth debate, so.
Well, I'm roughly new to flat Earth as well.
Okay.
John, can I ask you a question? Have you heard of the sun challenge?
Say again? Sun showers?
Have you? No, the sun challenge. There's a challenge to flat earthers to show an observation that they claim about the sun and about it going over the curve. Have you?
I have not heard of that one. But then I could actually, how would you test that?
Okay, a claim made by flat earthers about boats going over the horizon. One of the claims is that when you see a boat go over the horizon, if you think it's gone, that you can pull out high-powered binoculars or a telescope and zoom in, and you can bring the boat back, right? Well, and they say that's because it's due to perspective. Well, when we see the sun go over the curve, there's a challenge to say, wait till the sun goes completely down and to pull out high-powered binoculars or a telescope and zoom in and see if you can bring the sun back. Have you attempted that challenge?
But when you're zooming in on a camera, it's the opticals. You're not seeing further. You're just bringing what the camera can see closer. You're not.
Right.
You're making it seem like you'll be able to see it forever, and it doesn't work that way.
Well, no. I mean, the claim made by flat earthers is that if you see a boat go over the horizon and we see it disappear stern first, We can still see, like the sail and everything sticking out of the water that you can pull out binoculars or a high-powered telescope and zoom in and bring the entire boat back. So then the question is, if I see the sun go over the what I perceive to be the supposed horizon, shouldn't I be able to do the same thing? Pull out binoculars or a
Well,
high-powered telescope and bring it back?
well, like I said, I haven't heard of this one, but what you're explaining, I have, and I can tell you that between a boat and the sun, the distance is so much further of the sun that it wouldn't work the same way. But with a boat, it does work that way because when you're looking at the boat and your eyes, you only see so far. You can get a high tech or camera with a good zoom and zoom in, and it brings that same image closer to you. Therefore, you do see it again.
But you can't do that to the sun after it's gone behind what the perceived to be going behind the horizon.
No, because once the sun has gone so far that you can't see it anymore, and it has made that distance, it's out of the distance. Now, the same thing I'm saying with the boat, you still have to have a visual on the boat to be able to do that with the camera. You have to be able to still see the boat with the camera to zoom in on that boat.
Okay,
I'm not
so
saying because you can't the same way you can't see to London from New York.
Okay. Now, according to the law of perspective, it actually speaks on what you perceive, not what you don't perceive. So if you see half the sun, how is that the law of perspective?
Well, if you see half the sun, and depending on where you're standing, zoom in, you probably see the rest.
But you just said the sun was too far away to zoom in and bring it back.
Well, you didn't say that. You said when the sun has set and it's gone over the horizon.
Right.
That's what you
said
explained.
It looked like.
And you just said.
But you said if I see a boat going over the horizon.
But you said two different things, Gary. You said two different things. You said once the sun is gone, will you be able to see it again? And then just now you said if you only see part of the sun. They're two different times. If you still see it, then yes.
Yeah, I'm based on what you're saying, because you said you can still see part of the boat, you can zoom in and bring it back. So you're saying if you see half of the sun, you can use a high-powered telescope or binoculars to zoom in and bring the whole sun back?
Depending on where you're at, yes.
Love to see that.
And elevation. Well, have you done it?
No, I'm asking you if you've done it, because you claimed that
I haven't done it. And what I've perceived in different times I've done things, yes, that's exactly why I would believe you would be able to see it.
Oh, this is another unsubstantiated claim that you have.
You're doing the same.
Well, no, you said you believe it. I'm asking you for clarification. I haven't claimed that you can do anything.
No, I asked if you had done it, and you said no. So then you're doing the same thing by saying you wouldn't.
No, I was asking you a question for clarification. No. If you do this, will this happen? I haven't made a claim of anything to be done. I'm asking
probably
you
yes. If I had done it, if I do it, and if I did, most likely yes, it would.
But you haven't done it, so it's another unsubstantiated claim that you're making.
Well, you saying that I'm wrong, it'd be an unsubstantiated claim too. Seeing how you haven't done it.
Yeah, I'm not saying
I haven't done it. You can't keep asking the same question, Gary. Can you go to the next question? Because it's not going to change asking me again.
Yeah, I'm not asking you the same question. You're giving me different answers, and I'm just going for clarification to make sure your answers are clear.
Then let me clarify. I have not done it. If I had, then most likely I would see the sun.
Okay, but that's just another unsubstantiated claim. You're just guessing.
Well, I've done other things where you get a biopter, if you see it at a distance and it looks like a tiny little ant, then you get a high zoom and it brings it right back to normal size or bigger. That's exactly the same situation and scenario.
Is the ant moving away from you?
Sure, if it's walking away, I guess so. It's not walking to me, I know that.
Okay. It's your turn to ask the question.
All right. Have you seen the curve?
Yes, I've seen images of the curve, yes.
No, I did not ask if you've seen images. I said, have you seen the curve? Have you
Me
observed
myself,
the curve of your globe?
me personally, seen like the actual
Yes.
curve. No,
Yes. Okay.
no,
So, as far as you're concerned and your observations, you have never seen a curve of a globe.
no. I've seen observations that lead me to believe it is a curve. I have not seen actually physically seen the curve with my eyes. No,
Okay.
but
Have you
I have seen observation that lead me to believe it is a curve.
okay? Have you seen any land, any surface that has to make you believe that is a curve?
Lake Pontchartrain. What are you mean? Have I seen
How?
images of a surface, or have I physically
No.
seen?
Have you physically observed something that is actually gives you the truth of being a curve,
Oh no.
not observations of whatever. I'm saying on the ground. Have you looked out and seen the curve?
Okay, this is a similar question to one you just asked me. I have not physically seen
No, no, no. It
an
was the
actual.
same question, but you asked me to clarify.
Um,
No, I didn't. No, I didn't ask to clarify that. I have not physically seen the curve. I have seen observations that lead me to believe it is a curve. Me
um,
myself, physically with my eyes, I have not seen the curve. No.
I thought it was interesting that you brought up Lake Pontchartrain, Gary, because I've also been there.
Oh.
It's like in Louisiana, in case you don't know. And yeah, I guess I'll share a bit of what I saw there. I was standing on, one side of a lake next to, this bridge that, runs over the lake, and it's a pretty big lake. And what I saw was the bridge itself going under the horizon. I couldn't
You
see the.
you observe it. Your observation is of that, but that's just a perception.
Yeah.
But I just like saying, when a car drives down the road and you're standing there, and at a certain distance it disappears. That's like saying it goes over. No, it just gets so small and so far away you cannot observe it.
Yeah, I'm talking about the one I've seen is the picture of there are high powered power lines that go all the way across Lake
Okay,
Pontchartrain, and
well I can
all lined up.
100% explain that. I can explain those because when they drill and they set those lines in, they have to set them in at a level. So it's not like they're all just set at the same spot, and that gives you the observation that you're getting. Those are set
No,
at set points.
yeah, I don't know if you're
I
talking about the same. I don't know if you're talking
the
about the same
poles,
power lines. They are
yeah,
all, yeah, they're all set up same height all the way across the lake. But as
no,
you get further away, you see them curve downwards.
they're set up at a certain elevation to maintain the strength of the lines. And when you look down a hallway, the hallway gets smaller too, and it seems to go downhill. So are you telling me that a hallway that is straight is actually curving?
You're talking about two different observations because you can look at this one
No.
from the side. You're not lined up directly on them like you're on the hallway. You can literally go from the side and look at these, and they go straight in a line. They're leveled all the way across, and then as you
They're,
get to the end, you can
they are
see
not.
they start to dip down.
I'm sorry, they're not level. Because if they were level, they would have a funky shape to them because land is not always level. Matter of fact, there is
Wait a
not
minute.
1 inch of
Yeah.
land that is completely level. I can tell you that
Right.
because I'm a surveyor. I can tell you right now that they're
Well,
not
hold
set at the exact same elevations.
on. How do you know this? Have you been there?
No, have not been there, but I have surveyed over 1,000 sites. I can say I've surveyed over 15,000 miles worth of land.
I forgot that you said you were a surveyor.
Yes, I am a surveyor.
What?
In fact, no, I'm
What?
sorry. You called me a liar and said I wasn't a surveyor. So go ahead.
No, I didn't say you wasn't. I said you were a surveyor. I don't know if you're a surveyor or not.
Oh,
That
I
is
mean,
your
we can,
claim.
sir, we have a recording. You put it in the back chat. If you want to listen to it, you did call me a liar. That was actually why I did the whole calling out thing.
Oh, okay. Now you're a surveyor. What are the two type of surveys that they do?
It's plane and geodetic.
What's the difference in them?
A plane surveyor does small areas within a 300 square foot area, basically, or I'm sorry, a better within a 1 to 2 mile square radius, and then a genetic surveyor will do a plane survey over 100 miles or within 75 miles, depending on the company that's hiring them for what they're doing. When they do a freeway from zero, where they start a freeway, to wherever that freeway will end up, is the distance. Depending on that distance, they will use a plane surveyor or a geodetic surveyor. The only difference between the two is the amount of area they will actually survey at a time.
Right, but in a geodetic survey, don't they adjust the curvature?
They do not.
Are you sure?
I'm 100% sure. I've actually done my own research, to
Nope.
prove it.
Okay, can you show it? Because I want to see where it says that a geodetic survey doesn't adjust the curvature.
Okay. We have one more question then. We are very clear on the fact that they say that they have to use geodetic survey and adjust the curve to do, say, like the Golden Gate Bridge, right?
Yes, they did.
I just
Yeah,
want.
that's why. Yeah.
Okay. I have to share my screen, don't I?
Yeah, that's fine. Go ahead.
Let me see.
Okay. Here,
I'm trying to. There we go.
I'll stop presenting then.
I think you'll present mine, or you'll put mine on the screen.
Yeah. I'll you share your screen. I'll present it.
Okay. Are you presenting? Or should I go?
Yeah.
Okay. What you're seeing here is the blueprint for the Golden Gate Bridge. There's two different views on this blueprint. The top one is an aerial shot from above. The other one is obviously side view. The red line you see running across is a level line, does not curve, does not bow. From one side to the other side is a straight line. When you do the grades on that, the elevation on both sides from the bridge where these arches are on the left side to the bottom is exactly the same to land on the other end at the same point. Obviously, I'm not sure if anyone knows how the bridge is built. The bridge does not end where it hits land. It actually ends at this one. I think it is 3 feet in from where the actual land to bridge touches. It's actually the bridge other part is just an adjustment to that you can obviously get off the bridge onto land smoothly. But between those 2 points, it's level between those two ends. If it was a curve, they would be at different points. One would be lower. Obviously, they would be a lot lower than level. Then most would say, well, the bow in the front or the bow in the middle is obviously the curve. It is not. The same way a 40-foot trailer has a bow in it to spread the weight, it's the exact same way you have to do it with bridges. You can't have a bridge laying straight or bowing down, otherwise it would be structurally weak. As the curvature of the earth, the towers would obviously be bowed away from each other to have any structural integrity. If it was on a curve, the pillars are actually at 90 degrees to the bridge and 90 degrees to the base of the towers, which is not possible if it was on a curve. If the curve was added into the equation.
Yeah, you might need to check on those towers. I don't think that's correct.
They're 100% squared. I mean, you can look at it right now and tell that they are not bowed in any situation or anything. They're 90 degrees on both sides. Now, if you would like a protractor, I'll hold the picture up there long enough for you to do it. There's nothing about the way the bridge is built that accentuates a curve.
Alrighty. Okay. Thanks for sharing.
I have other bridges too, so if you want to do those, Gary, I'll do those too. I have actual pictures and observations of why I believe it's flat. I would like to see your observations and proofs of it, research you've actually done to tell me these things. Because like I said, 99% of the time, it's not what you've done or observed yourself. It's what they tell you and you repeat.
Gary, your mic's muted.
I'm sorry. Right, but the picture you showed is what something apparently someone told you. That's not the information that you got because you didn't work on the bridge, right?
No, but I can read blueprints, and so when I have the blueprints, I can look at it, assess the elevations, do my research, and show how it is. I believe it is flat, and then present it to you. I can look at any planets and do the exact same thing with anything. It's nothing I had to have to put my hands on.
Right, and in these blueprints, it tells you the measurements for the towers.
Yes, I can. Do you like the information on the towers as well? Because I can. Like what? Well,
Show me that
grab
they're
it.
the same. That they're the same height and that they're at 90 degrees.
No, it doesn't say it's 90 degrees because I don't need to tell you that when you're doing any observation. Let me pull up. Let me find my work on it, and I will give you all the information you need.
Well, you just claimed that those towers were at 90 degrees, and now you're saying they're not.
No, I can say they're 90 degrees on the plan blueprints and in their plans. There's nothing that would give them a reason to say these towers are at 90 degrees. Construction and blueprints don't work that way.
But you just claimed that they were at 90 degrees.
Because when I look at those blueprints and when I put my instruments onto it, I can tell you they're 90 degrees. The same way I can tell you the distance by using the scale. So you're telling me that if I use a scale ruler, I can't tell you how long it is?
Are you talking about for the blueprints?
The blueprints and the bridge are basically the same things when it comes to telling you exactly how tall, how long, or whatever else information you need. The same way it was for them to build it.
Okay, so you're saying they're 90 degrees on the blueprints, being in the drawing, but are they like that in real life? That's the question.
Gary, that was a drawing. It's a blueprint. That's what they used to build the bridge. That is the specs of the bridge.
But the specs don't say what angle the towers are at, does it? You just said that
Let me explain this again. The blueprints is what they use to build the bridge. When they go, where do these towers need to go? They go, look at the blueprint. The blueprint tells you from one point, which is called a bench point. They tell you how far it is in. They tell you where it stands and where it sits and how they're supposed to be angled. Now, it doesn't say 90 degrees, but it doesn't say, hang on, it doesn't say 90 degrees, but it does tell you where the base of those towers need to be at one spot, and it tells you where the other spots, say 15 feet up the tower, need to be. They tell you the tension of those strings. They tell you where the tip between the 2 points on the towers need to be to each other. So there is a distance between the top of the towers from each other. There's a distance from the bottom of the tower to each other. They are on the blueprints. It is a gimme. It's not like you're making it seem like what I showed you isn't what they use.
I mean, what I'm saying is you haven't been specific with how you're presenting the blueprints. You're leaving out.
Okay, I'm sorry. I laid a protractor on top of the blueprints, and the protractor told me that the bridge and the towers are 90 degrees, or at 90. There's a 90 degree right there.
Right, but
that make you happy?
Right, but you made the claim that it tells you how to build them exactly, and that it tells you what angle to put the towers at. But then you also made the
no, I did not tell you. Gary, stop doing that. I did not say the blueprints tell you the angle to put them in, because blueprints don't tell you an angle to put them in. They tell you a distance from a bench point. Now, if they tell me the base of the towers go here at 10 feet, and the towers go here at a certain amount of feet, and then the distance between the two towers, I can tell you it's at 90 degrees.
So what's the distance?
I can use my tools. I can put my tools down and tell you exactly where every angle is and what the angle is to whatever it is.
Tell me the height of both towers.
Okay. Right now I'm looking through my notes and I will tell you. because most people understand that blueprints do that themselves, and that you're making it seem like my blueprints are a fictional drawing that I made.
No, wait a minute. Did you make the blueprints, or did you get the blueprints from somewhere?
I got the blueprints from the San Francisco register office.
Okay.
Okay, so after this, yeah, we have a question from an audience member, and yeah, I would like to pose it.
Go ahead. Yeah. I mean, you can go ahead and do that now while I'm looking. I have no problem with that.
Okay. It's back to the vacuum. Okay, and it's from Barney. What would happen to an object in a vacuum tube if there was no gravity? Would it float?
Um,
It depends on the
I
object.
don't know.
Which object? Like
It wouldn't matter the object. It would
yeah.
It'd be
well,
yes or no.
If it's water, if it's water, it'll form into a ball. Most objects would just float.
Okay.
It would. I have no clue. I would imagine that it would most likely float.
Alrighty.
I'm assuming mainly because there would be no atmospheric pressure in that at the same time. Like I said, I don't have a vacuum, so I couldn't give you a guarantee this is exactly what would happen. I'm not willing
Let
to.
me ask
Well,
you,
in a vacuum tube, it's a vacuum tube. There's no gases in there. None of that's vacuum.
Yeah. There's no.
Let me ask you about your buoyancy and density argument. What happens to a helium balloon in a vacuum?
I have no idea. I've never seen it.
In a vacuum,
can I ask a question?
Well, hold on. I was going to tell you. In a vacuum, a helium balloon, it falls to the ground just like everything else at the exact same rate.
And you've seen this, or you've done it?
No, I've seen
Which one?
it in an experiment.
Okay. I don't think I've seen it.
I'm trying to think who did the experiment. It may have been Ace Labs, because he has a vacuum chamber, and he puts a helium balloon in there, and he slowly starts sucking it out, and you can see the balloon rise at the top, and then you can slowly see it nice and fall. But if
is that the one where it's like it's like the size of a average size safe?
No, I know what you're talking about.
Okay, I'm just asking. I didn't know. I didn't know if it was that one or not.
This is just an amateur guy. He's amateur. He does a lot of experiments inside of a vacuum. He shows how water boils inside of a vacuum. He shows what happens if you put flies and other insects inside of a vacuum. Like normally,
can I ask you a question now, Gary? Can I ask a question?
Sure. Go ahead.
Can you explain to me how water bends around the globe?
Well, when you're saying bend, you're asking me how does it conform to the Earth? When we say level on a curved Earth, we mean it's 90 degrees of gravity. So if it's
explain
90 degrees of gravity, so
can you?
It means that the surface of the water will always stay 90 degrees of gravity. So all the way around the ball in all directions, the surface of the water will always attempt to stay 90 degrees of gravity.
So that is your idea of how it works.
Well, that is our explanation of how it works in level theory, which is another established theory.
Okay. Shawn, did you find the stuff you're looking for in your notes, or?
Yeah, I'm still looking. I got a lot of notes.
Okay.
I'm trying to remember on the Golden Gate Bridge if the towers one is a little bit taller and one is shorter than the other one, or if it's the tilt, but I can't quite remember on the construction of those bridges. But I know there's a difference in those towers that account for the curvature of the Earth.
Oh, okay, found them. No, both towers are. The main tower. Where am I looking?
Okay, so we got a question from CRISPR. Can you name a navigationally accurate flat Earth map? Yeah, obviously this
No.
one's addressed to. Okay.
The problem with that is that we can't make the same measurements the same way you would do it. Like, for instance, I don't have enough money to go around the world, therefore I can't do all those tests myself. When it comes time to do, say, your Antarctica tests, you are not allowed. We all just can't go to Antarctica. You have to have special written permission, military escorts, and a lot of money. So it's kind of difficult to do that and have accurate test everything.
And in your model, Antarctica's all the way around the planet.
Yes.
Why is it ice?
Why is it ice? Because it's cold. It's very, very cold, Gary.
I mean, why?
Why is your Antarctica ice?
Because it's on the bottom of the globe and it gets less sunshine.
Yeah, well, ours gets less sunshine too.
How? I don't see it
Sure,
in your model. See, in your model, the sun's not a spotlight, which means half of it would be lit up, and then the sunlight should just go all the way around. I don't understand why it's frozen all the way around.
Because it's not above it. It doesn't go above it. It's still very far from it. Very far from the sun, just like your version of what you think is there. For their answer, the towers above water, they're both at 746 feet.
And at the base?
Say again?
What's the there's a difference? There's a difference in those two towers. I know that for sure.
No.
I'm just trying to remember what it is.
Okay, well, your remembering isn't going to change what the blueprints tell you. Tell me, and both towers at 746 feet above the water and 500 feet above the road.
No, what is the differences in the base of the towers? Because I know they adjusted for the curvature of the Earth, and you can see it within those two. With those two towers.
Both towers from the base, or I'm sorry, from the mead line on the water is 746 feet, which means they found a level in between high tide and low tide, and they measure up. Therefore, they are both the same height. You're saying that they adjusted for curve. If they adjusted for curve, one would have to be one height, and the other one would have to be a certain other height, and they would lean away from each other. They do not lean away from each other. The foundations, and then the foundations, which is the bottom of the base, is 110 feet below the water mead line. You understand what a mead line is, right? Jerry?
Gary, your mic's muted again.
Okay, sorry about that. Okay, now I remember what it is. They're a little wider at the top than they are at the base. That is the adjustment for the curvature of the Earth.
Okay, can I explain that too?
Sure.
Obviously, I mean, I shouldn't have to. The tower, the base is going to be a lot wider than the top because it has to be. That's how it works.
I thought you just were trying to make the claim that they're built at 90 degrees equal. And so how would they be wider at the top than at the bottom?
Because one is the base and one is the top. I didn't say they were rectangles going all the way up. But
now
the distance
I don't think you know what 90 degrees is.
Okay, well, you need to look at the blueprints again. Can you want to share that again? Because I can get a protractor. Maybe you can do a protractor. You got a flat screen, right, Gary? Because you can measure. You can probably measure it on your screen as well.
I finally looked it up because I couldn't remember what the difference in the towers were. They're wider at the top than they are at the bottom. The distance.
Okay, look at the blueprints. Look at the blueprints.
Yeah.
Do you see the blueprints, Gary? You see them? See how the base is wider because it has to be able to support the tower?
Does the blueprint indicate what angle the towers are at?
The angle, no.
Okay, so they could be wider at the top and shorter at the bottom, right? That would pretty much kick your 90 degrees angle right in there.
Not at all. You want to know why I know? Because right now I'm looking at the numbers and it tells me the size of the tower base is 33 by 54 feet. Now, are you telling me the tops of the towers are the same?
No, they're
That is
different.
what's
They're
giving
wider.
you a different. That's what's giving you your different number, because you're saying that because the base is wider, that the top is obviously curved, or it accounts for a curve. It doesn't work that way. The way you would look for a curve is you would measure from the middle of the base all the way up. And I can tell you, if you are looking at the plans, are you looking at the blueprints I have up? I'm not sure if I have to share it. I'm sorry. Can I share the blueprints again, sir?
Yeah, go ahead.
Thank you, sir.
Yeah, I'm sorry, I couldn't remember what it was about those the bridge, but I knew there was a difference in the towers. I just thought I couldn't
There's
remember.
no difference. You're just making a difference, Gary.
No, I'm not
That's
making a
the only
difference. It's well documented that they're wider at the top than at the base. But
Where are you looking?
try
Because I would love to
make
see that.
it.
Okay. Do you see the base? See the
Yes, I
base?
see the base. Huh?
Okay. Do you see there's a line that runs in through the synthetic dirt, the middle of that base?
Oh, okay, but you've already said these blueprints don't show the angle of the tower.
No. You see, you're doing it again. You're trying to adjust what I said and what you asked me to match what you're saying. But I told you on these blueprints, it does not say the towers are 90 degrees. But
Right.
because I know how to read blueprints, I can do my own observational test to tell that they are 90 degrees. How I do that is exactly what I'm explaining to you now. Because if you go to the middle of that line, or the middle of the base, you see a line that runs down. Right? You see that line?
But
Gary,
does that?
you see the line?
It doesn't tell you. It doesn't tell you.
Just answer me. Do you see the line?
Okay, this is what I want you to do. I
Yes,
want
okay.
you to look.
Do you see? Oh my. Okay, Gary, you're trying to adjust what you're saying and asking me to tell you that it doesn't say 90. Guess what? The plans do not say, hey, these are supposed to be 90 degrees to the bridge. But I can tell you exactly how I know they're 90 degrees. I can prove it. I can explain it. Everything. If you let me. Can you let me do it?
Well,
okay,
you can attempt to explain it, but you need to say on the
Gary.
blueprints where it says those towers are 90 degrees.
Gary, you need to let me explain it without you telling me I'm wrong, because I don't even explain it. You're probably not even looking at the blueprints right now.
No, I'm looking at them.
Okay, then just look at them and let me talk. The line that runs down the middle of that base is your center line, the center of that base. That center line is centered and runs a straight line to the top of that tower. If it was adjusted on a curve, that line would not be a straight line. Now, when I run that line along with the mead line that you see under the bridge, it gives me, on my protractor, a 90-degree angle, showing me that those towers are not at any angles besides the 90 degrees that I calculated and I measured given the lines that the blueprints that built that bridge give me.
Show me on the blueprints where it says that the base of the towers are the same.
You're the only person on the face of this earth that doesn't listen. That's exactly what it is. I already told you it doesn't say it says 90 degrees, but I told you and I explained very clearly how to tell they are 90 degrees.
So it's another unsubstantiated claim.
No, Gary, it's proof. It's 100% proven. Because I know how to read these blueprints and I know how to explain these blueprints. You're the only person who isn't listening, obviously.
No, I'm listening to you. You're showing me blueprints that don't support your position. And
how does it not support it?
Because it doesn't say that the base is the same width as the top. It doesn't even say that the towers are 90 degrees. That's a claim that you have made that the blueprints don't support
using the blueprints.
The blueprints don't say that.
Okay.
That is something you are adding. You're
100% right. It doesn't say in big Gary letters that it says 90 degrees. Do you know how to read blueprints, Gary?
Yes, I know how to read blueprints. My
Okay,
question
well,
is,
perfect.
why are
Perfect.
you making
Okay,
the assumption that those
I'm
towers
not
are
making an
90
assumption.
degrees?
I'm not making an assumption. I am telling you right now. And since you know how to use blueprints, then this should not be a problem. Do you see the center line of both towers?
Yes.
Do you see the mid line under the bridge?
Yes, but what is the distance for
What
the
is a
top
mid
of the
line?
towers, and
What
what is the
is a
distance for
mid
the
line?
bottom of it?
Explain to me what a mid line is.
Answer the question. You're avoiding the question.
No, I'm
Explain,
100% proving that you're trying to
explain,
just be an asshole right now. What is the mid line?
explain, explain on these blueprints where it indicates the distance for the bottom of the tower and where it indicates the distance for the top of the tower. Show me.
How do you find 90 degrees and 45 degrees and 35 degrees? How would you
These are
find that?
these are blueprints, right? They would
Yep.
tell you the distance for the base of the towers, and they would tell
Okay.
you the distance
I'm
for the
not
top of
sure
the
if
towers.
you noticed or not, but this picture of the blueprints isn't make it very possible. Now,
So
hopefully,
how
it
are
will.
you
Okay,
making
I'm going
these?
to do it right now.
How,
Hang on. Stop. I'm going to try it right now because I have to move. See this? See that line right there? See that line? I can't
I,
move. I can't
I don't
zoom
think you
into it
understand that
because
that
this is in
picture
the
is
way.
yeah, that's extremely small for me. I mean, you can zoom in, but I want to see what you're talking about. That it gives you the distance for the
Okay.
base and the top of the
Well,
towers.
moderator, I'm going to have to stop sharing for a second because to be able to zoom in on my blueprint
That's fine.
behind this little box right here.
Okay.
Okay.
Yeah, I'm not trying to be mean to you, Shawn. It's just those blueprints don't support your claim. I understand you're making the claims, but the blueprints don't support those claims.
All right. All right. You can see it now?
No, you're not sharing. There
It
you go.
should be. Thought I did.
Now you are.
I am? Okay. All right. Like I said, for to really work, you'd have to be staring at the blueprints itself. But as you can see, the distance between the two is sideways, but it is 4,000. See, I can't see which one. Oh, from the piers, it is 4,200 feet. And on this one, it only gives the right angle at 746 feet. So off the mead line, like I said, the height of that tower right there is 746. And then, see, I can't zoom in again. The best I can do is, hang on, I'm going to stop it and I'm going to pull up the one without my markings on it. It's the only way I can do it, where I can see the other tower as well. I have to be doing this because the lines do exactly what I'm trying to tell you. But I understand. You like the difficult, so I'll go ahead and include differentness.
Now, Shawn, let me ask you: if it was proven that you're incorrect about those towers, that the that the base is that the top is wider than the base, would you conclude that that would prove that they are adjusted for curvature?
No, because I can tell you the base is 33 by 54, and the top isn't.
So you already know that the top is wider than the base.
I didn't say wider. It's the dimensions of it is bigger. That's why it is shaped the way it is. Now, wider is completely different because there are actually 4 different bases on it, not just one on each tower.
Right, but from tower to tower, the distance at the top is would be. Uh, I mean, I don't know any other word than wider than the base.
Okay, so there's wider and thicker, right? Thicker is thicker than the top. Wider, there's also four bases on there. So if you're going to make it seem like that, then yeah, you're 100% right, Gary. There is a gap between the 2 bases on each tower. That does not have anything to do with a curve. That's just wide.
The gap that's in the middle of the towers. At the base,
yes,
it's shorter, and at the top, it's wider.
Because the base is thicker. It has less area between the two. Like what's the difference? Okay, I'm pretty sure it's going to be the exact same as the offset as the base. That's why you're not making any sense. That the wide isn't the top as thick as the base. Now, wide and thick are 2 different things, and like I said,
they measure them from a center point. They don't measure it from. I mean, I guess the from wall to wall. If that's the comparison you're making.
Gary, I've been trying to explain to you that they run off a center line, and you told me I was wrong every time. Now you want to use that center line.
What are you talking about? I didn't tell you anything about they didn't run off a center line. I just told you that if they're measuring from the center line of both pillars, that it is shorter at the bottom and wider at the top.
No. Well, you tell me what it is then.
Well,
I can look at the plans and say exactly different.
The claim you just made is the reason why they are shorter at the bottom is because the bottom is thicker, but they're measuring from a center point, so the thickness would be irrelevant, wouldn't it?
I don't understand what you're saying, but either way, I know it's not.
Okay. If they're measuring from a center point, how would the thickness be any?
Okay, go ahead and say what you got to say.
Well, no, that was the question. If they're measuring from a center point, how would the thickness be relevant to determine if it's wider or shorter at the bottom?
Whatever you say, Gary, because you were saying the exact same thing to try to prove your case. Now go ahead and finish what you're saying, so I can show you exactly why it's not the way you're saying.
No, I'm asking you a question. You said that the base is thicker, but I just pointed out that they were measuring from a center point. So if they're measuring from a center point, how would a thicker base account for it being shorter at the bottom than at the top? Maybe you didn't hear the question. I don't know. Did you?
No, I explained exactly, like you're asking me a question that I just explained to you is exactly how it is, and you want me to change my answer, but I'm not going to, and I've said that twice now.
Which question? You answered the question?
Exactly how this line runs straight up. It's a 90-degree angle along this line, the midline. So if you would like to tell me different or explain different, please show me how it's different.
I'm telling you on the bridge from what I just read that it is shorter at the base and wider at the top, and it's measured from
screen share. Please screen share your proof.
Well, I can't screen share right now. Give me a moment, and I'll try to set up a screen share for you when I get home.
Okay, thank you.
All right.
Just tell me that does not work for me, because I can tell you it is.
Yeah, we've been talking about the Golden Gate Bridge for a while now.
Yeah.
Why don't we move on instead to some of our other audience questions?
Okay.
Okay, yeah, we gotta. Yeah, all I see are questions directed to you, Shawn. Okay, what is sunset on a flat Earth? Um, shit, my bad. Where did it go? Um, what is sunset on a flat Earth? How could it occur geometrically and still explain how half of the Earth is night and half day?
Uh, I don't know. I don't know how to explain it. Like I said, I'm not a meteorologist, so I don't know how all the clouds and systems work, regardless of which cloud to be speaking of. So the best way I can explain it is that it's too far to be a daytime, so the sun doesn't shine forever, and it's not 93 million miles away, so it's not going to just shine everywhere all the time.
Okay.
My question would be, if your sun isn't a spotlight, what makes it light up only half the planet and not light up the other half, based on the distance?
It's not a forever light, so why would it shine everywhere all the time?
It doesn't have the same function as light. Why does the light stop?
Because the distance. If you put a flashlight up, it doesn't shine to the mountain 100 miles away from me that you could see. It's not enough power. The sun isn't 93 miles away, and it's not what 100. It's what do they say? 100 times bigger.
What's the distance from the sun to the Earth?
As far as my best, I would probably range in about 10,000 miles away. Maybe I don't know. I have no clue. I'm not an astronaut. I've never been there to see exactly how far it is.
Okay.
Do I get questions, or do I only get these questions? Does he? I mean,
No.
I would like for him to have questions and not just be questioned the flat earther time.
Oh, I'm not sure. Is there any audience questions for me?
I mean, I'm pretty sure I can come up with some.
No, Gary, there's none for you. So, Shawn, you can go ahead and ask Gary questions.
All right. How could it's pretty cut and dry. I mean, if you can't find a curve, there's no curve. It's not really a question to be asked about it. How do you explain? How can you explain it being sun being 93 million miles away, or better yet, I have a better question. How do they have tens of thousands of satellites and they're not constantly having to fly new ones every single day because they smash into each other?
Satellites would be placed in geostationary orbit. They wouldn't smash. Well, sometimes they do smash into each other and they fly off.
Wait. So you're saying that they're stationary up there?
Well, no, they're actually, well, they're spinning with the Earth, but some of them do get hit and knocked out of their orbit, and they actually do fall to Earth. But usually they burn up in the atmosphere. But some of them also fly off into space.
So, luckily, DirecTV and we'll use Nextel because they're a good company. Their Nextel satellites, those ones, they never get hit.
I don't know if they get hit, but I know they get repaired. They could easily be hit.
How do they get repaired? They don't send astronauts they wouldn't do that.
Actually, astronauts would do that. Sometimes astronauts deploy satellites.
Have you seen what NASA depicts as what all those satellites look like out there? not to mention the distance of where the satellites are, and the furthest we go now is 210 miles, I think it is, and satellites are supposedly far higher than that. So when do they have time, and when do they do this?
I mean, what do you think NASA does? I mean,
NASA basically does research on the ionosphere, the stratosphere. They help the military, and they sit in a box a few hundred miles or 100 miles up, 120 something miles up, maybe.
yes, and they also repair satellites for companies.
Okay, I never heard of them doing that.
Really? That's fascinating.
Can you show me
Can I tell you what?
an example of that?
Well, yeah, I can tell you right now that NASA is working on expanding their vacuum chamber so that they can put whole satellites in there and test them in the vacuum chamber so that they can make sure that they work right. And they also do that for companies. Companies actually pay them to take their satellites into orbit so that they don't have to have their own rockets and things like that. Like
Oh, wait,
every company doesn't have rockets or launch pads, so they usually pay NASA, and then NASA will, of course, launch those up. Sometimes they send single rockets up there, and sometimes they're actually inside of the spaceship. That's why it has a cargo hold with a crane on it. I mean, what do you think the crane is for?
it looks good. I know that.
Oh, it's there for looks. Gotcha.
Yeah, apparently.
They put a big crane in there for looks.
Yes.
Okay.
Okay. I would like to present in a second.
Mm-hmm.
Okay.
And I gotta find the right one I'm looking for. I want to make sure it's not like a conspiracy theory site I'm going to. I want it to be a legit one. Or half-assed legit at least. All right, I guess they do give that one. Okay, I'm ready. Where's that? You guys there? Okay, there it is.
Yes.
All right, sorry, I thought I had accidentally pulled it off. Hang on. Let's do the entire screen. All right. So you're telling me all these dots, which they're saying is all the satellites, they're able to maneuver inside this.
Yeah, I don't see. Oh, there it is.
Oh, okay. Hold on. I can see it now.
Yeah, I wasn't seeing it either.
Oh, I know what you're saying. That depiction. Yeah, that's a depiction of about how many satellites and other things they have in orbit, or space debris junk. Yeah.
So you're saying that they're able to maneuver between all this stuff.
What do you mean maneuver? It would be like if somebody threw that many baseballs in the ocean. I mean, what do you think is going to happen? Are you going to tell me they can't maneuver?
Well, a million baseballs on the ocean aren't traveling at 17,000 miles an hour.
Right, but I'm trying to give you a depiction of the space that you're talking about. If you threw that many baseballs in the ocean, I mean,
okay, but what you're saying is actually a small area compared to the amount that are actually in that. Look, what you see there. You're telling me at 17,000 miles an hour, they just pick them out of the sky and fix them?
No, what I'm trying to give you an example is that the baseball is a representation of a satellite in the ocean.
Well, a baseball is a little bit smaller than a satellite, so I would like you to make a better depiction.
No, I'm trying to give you an example of it's kind of a little example of a satellite would represent the baseball, and the baseball in the ocean is just a small drop in the bucket. So I understand you showing me all these pictures, but once again, compared to the size of the Earth, a satellite is just a small baseball in an ocean.
But what you're telling, if you had a baseball in the ocean, that would mean you would have to be the size of we'll say, a beetle picking those out of the sky.
In relation to the Earth,
Because
in
you realize that satellites are pretty big, right? I mean,
yeah, if they're redoing an entire vacuum chamber that held the lunar module in there, then yes, I understand it's very big.
and how big is the lunar module?
The lunar, it's the same. Well, I don't know. I have to look at the dimensions to give you the exact dimensions for the lunar module.
Then how do
But
you
it
know
was.
that's exactly how it's going to do? Oh, I'm sorry, I forgot. You're right. Okay, NASA told you.
Well, no, I've seen photos and documentary on it where they tested it. I was looking up on the vacuum chamber because I wanted to know what the world's largest vacuum chamber was, and NASA is actually expanding that same vacuum chamber that they've had for years.
Okay, well that I don't really depict that. That's what they do up there. I've never heard of that.
You didn't know NASA works on satellites? I mean, really? Well, you know, I think you cut out. Did he cut out? Maybe his mic dropped out.
He did for me.
Hello?
Okay, I can hear you now, Shawn.
I don't know what happened. From the documents and stuff I have, they're not doing that. They're more rather doing other stuff that I'm not sure. I mean, well, they're doing a lot more like weaponry and military stuff than fixing satellites. I don't think they're fixing satellites at all.
Oh, okay.
I mean, I actually have documentation from government documentation that says that's what they're doing. I mean, that's why I asked if you had something to show me for that.
Well, I can show you documentaries where you see them actually working out in space, and they have the nice crane. And if you look and see what's attached to the crane, it is a satellite, and that is what they're doing. They're deploying the satellite.
Okay.
They also use it
in that respect. I would like to see documents. I can show you documentaries and videos too.
Hang on. Gary wasn't done. Gary, what were you going to say?
My apology.
No, that's fine. I understand he wants me to pull up documents, but I mean, I'm pretty sure it's part of the public record because NASA is, publicly funded. I'm pretty sure it's a public record who they do work for, and probably what they paid NASA, because that has to be part of that information.
Okay, so are you saying they don't work for the government?
Who?
Or I'm sorry, Department of Defense, Department of Secretary. They don't work for the military.
Who don't work for? What do you mean?
NASA.
NASA. No, NASA.
I don't understand what you.
NASA's not part of the military.
Okay. So you said. I just want to clarify. I'm not sure if I understood. You said that because we pay for NASA, which is actually $59 million a day, all their information is public records, right?
Well, there are some top secret, but for the most part, information about NASA is part of the public records. You can request that. It's actually listed on. If you go to the government page, they'll let you know. And you can actually look up receipts for who they do. What companies paid them to go and repair their satellites. That's part of the public record, I'm sure.
Okay. I'll give you. I don't know if the moderators will get willing to. I'll give you the time to find at least one that HARP or the Department of Defense has paid for, because I can show you records where they do work for them, and I'm pretty sure figuring out the ionosphere and other stuff like that is pretty much more important than satellites, and I can show you dates and proof that they're doing this. So when you say that they're fixing satellites, and I tell you I don't believe that, I believe they're doing more research on the ionosphere and the stratosphere. That makes more sense to me.
What makes more sense to you? That they're doing what?
That they're doing more work for the military rather than for direct TV.
Well, they do it for whatever company actually, pays.
Well, I'm telling you right now, the military is.
The military repair satellite. Is that
No,
what you're
the
saying?
military pays NASA to do what NASA does for them. I mean, I have records of them doing stuff. I have records of what they're doing now. I mean, that's why I'm asking. That's why I asked to see something. I mean, I was asking you to show me that there's some kind of evidence that they're up there fixing rock or satellites, and you said that they has a crane and whatever's in its arm is it. But I would like to see them fixing a crane or picking a crane out of the sky at 17,000 miles an hour, or a document saying that's what they're doing. Do you have one?
Well, I mean, I can go to NASA's website. Let me see. Robotic eye in the sky.
That's why I stated I wasn't sure if that's we have time for that or if it's allowed. But I would love for you to show me some kind of records of this stuff.
Yeah, sure.
Cool.
Okay. Hold on a second. Let me get this.
Yeah, I wasn't planning on going this long, but I mean it's been an interesting talk. So
I mean, it's kind of hard to get my side across when there's like I mean 100% get that everyone that's watching your channel is going to be globe that believes it's a globe, so it's kind of hard to get some of the stuff asked to him, or you know what I mean. I'm only one person here, where there's I'm sure dozens in the chat wanting to know different things that you can pick from.
yeah, we're ganging up on you.
Nope, not ganging up on me at all. I'm just saying that I don't have a number of questions to ask him like that. So the things that I can think of to find out, these are the things I can think of myself. But I don't believe you're ganging up. I believe you've actually been a very good monitor. I have zero issues at all with that.
Well, okay, I should have said like the people in the comments are kind of ganging up on you.
Oh, no, that's expected. I trust me. I completely get it. I'm a flat earther. I've heard it all. I've dealt with 10 million times worse. But the for me personally, it's just because. I mean, unless you can observe things that you feel we're not being truthful about, all you're really doing is just playing the repeat game. And as far as I'm concerned, I am much more comfortable believing in what I can test, research, and prove myself. I'm pretty sure. I mean, at this point, it's not really going to be a what side made a better argument. No one believes a damn word I'm saying. But at the same time, how many people have ever seen a curve? How many people? I have the means to prove that from here to Arizona to the next state is flat. But everyone else that doesn't will still continue to tell me if there's a curve.
Okay, there's two Garys now.
Yes, I'm going to screen from my computer. Hold on a second.
Oh, okay. Oh, gotcha. You're on your phone too, I see.
I mean, we've had this conversation before, but Gary's main thing of gravity, I mean, there was no way of proving it. You could go through all the little scientific ideas of what it is, but it's not a proof. Gravity is not something that is point blank case how it is. It's just not how it is.
Okay, Shawn, can you see my screen?
Yes.
I'm presenting.
Yes.
Okay.
Yeah, I'm presenting to everyone.
Yeah, what they're going to be showing you is them actually repairing a satellite in space from the space shuttle. Is this going to be good enough for you? I don't know. It may be.
Yes, it is. Well, yeah, for me.
Mhm. Let's go back a little bit. They'll show you them finding the satellite, raveling it, and bringing it into the space shuttle.
Okay.
You see the satellite?
Yes.
And they're
Is it
going.
playing right now? Can I ask you
Yeah,
something?
sure. Go ahead.
Well, I'm going to wait until I depart, and then I'll ask you because there's something I already noticed that is that problem. And this is happening at 17,000 miles an hour, right?
Well, yeah, it's happening within the atmosphere. The planet is spinning at that, but they're spinning with it because they're actually still within the Earth's atmosphere, low
Wait,
atmosphere.
so they're not in zero gravity?
Yes, they're in zero gravity.
Okay, but so then they are traveling at 17 because that's how they stay up. They don't. You do know that, right?
Yes.
The Earth is. They say the Earth is constantly pulling.
Yeah.
Okay, just checking.
You see them grabbing the satellite.
Hmm?
This is
I see. Yeah.
This is the thing. Yeah, this is the thing that NASA does: repairing the satellite in orbit.
Mm-hmm. You may have to rewind it.
This,
I'm not
this
sure.
is from
I'm not sure if they're.
this is from 1992, and you're asking
Okay,
me if
I'm not
they
sure if they're going to show. Are they going to show them in Earth again?
in Earth again.
Yeah, like in the
No.
beginning, you could see the Earth, and like them and the Earth together at the same time. Can you go? Can you? I think if you go back to the beginning, it'll be easier. Okay, yeah, around that area is fine. That's playing regularly, right?
I'm sorry.
Now you're playing.
Yeah, I'm playing. I went back to,
Oh, okay.
I guess, before they grabbed the satellite.
Here's the problem. If they're going 17,000 miles an hour and the Earth is going 1,000 in the other direction, please explain to me why that Earth isn't moving.
Because the shuttle is moving with the Earth. That's what you're saying. Is they're moving.
Wait, so they're traveling only 1,000 miles an hour now? Because even NASA says they have to be traveling at 17,000 miles an hour to equate the force of gravity still. So
yeah,
they
they're
do
moving
not.
They're in orbit moving with the planet.
The planet only goes 1,000.
Okay.
And they have to travel at 17,000 to stay in the air, stay up. You know that, right?
Yeah, they're not going the exact same speed, but they are moving with the planet.
How do they move with the planet if they're going 17,000 miles an hour and the Earth only rotates at 1,000?
Right. Once
I'm
again,
not understanding.
they're not going the same speed, but they are moving along with the planet.
So shouldn't they be? You see the rotation going fast then?
What do you mean see the rotation going fast? You will see a slight rotation. It's a large object. I don't know what you think you're going to see.
Because at 17,000 miles an hour, they should be moving faster than the Earth. Or you're telling me the Earth is going straight in a straight line at 17,000?
What?
I'm not understanding how you're saying this. Okay, so you know that
I'm not understanding exactly what you're not understanding. The planet is moving beneath them. They are moving as well, but they are moving in the same direction.
In what direction? You're saying in the same direction. See, because what I'm seeing is the ass end of that shuttle pointed towards the Earth.
Mm-hmm.
And them going that, which means they would obviously be going the opposite direction because you can see the Earth is going one way and they're facing the other, but they're moving at 17,000 miles an hour. That is not what that would look like. Those clouds would be shooting across that screen because they're moving so much faster than the rotation.
Wait a minute. How are you basing? What is your basis for determining what it would look like?
Because 17,000 miles an hour to 1,000 is a big difference, Gary.
No, what is your reference point? You are claiming that it wouldn't look like that based on what?
Based on the fact that they say satellites can revolve so fast. I mean, you can go on a tracker and see that it doesn't take that long to. If it's that slow, then I don't understand how satellites are revolving around so fast.
No, my question is, you have said that there's supposed to be a specific
all the numbers I'm giving you and the speed in which it should take to get around the Earth are based off of NASA trackers that they have all over the internet.
Yeah, you said that you should see a specific observation on the video. What are you basing that on?
On the feeds that NASA puts online, I can put up a 24-hour one that they claim is the Earth going around, and it's much faster.
Is this not consistent with what they show? Because it looks like it's consistent for me, but I've seen
No,
several.
actually, it's not because I've seen that so-called Earth picture moving faster, and I can show you
Well,
that.
what's well on the one that when it's moving faster, what's the distance for the shuttle to the Earth, and what's the distance of this one to the Earth? Is there a
Well,
difference?
seeing how there shouldn't be a difference at that speed, they have to be a certain distance out of the atmosphere to be even able to do anything. So
No,
whether
I
they're
mean, well, hold on. Let me clarify this. The human eye, you see things differently when they're further away than when they're up close. You know that, right? When things are up close, it seems like they're going faster. When they're further away, it seems like they're going slower.
yes,
That's
Gary,
what
I
I'm.
know that. That's very
So,
obvious.
so if this shuttle is further back, then the Earth would seem to move slower, and if the shuttle was closer, the Earth would seem to move faster, right?
Okay, so the Earth is that big that obviously, because you said it's so big, it just looks like it's moving that slow. But you're telling me that those astronauts doing 17,000 miles an hour won't be moving wouldn't be moving very fast looking, right? Between the two, because obviously, no matter how far away they are from each other, especially because they're going in opposite directions of each other, they would look like they're moving a lot faster.
Look, I'm not sure if you ever seen a plane take off, but when I see a plane take off,
100%.
to me
I
it
have.
doesn't. Yeah, it doesn't seem like it's going 300 or 500 miles an hour when it's taking off. That's because I'm
They
so
don't
far
go. They're
away.
not. They're not going 500 miles an hour when they take off.
Well, I know. I mean,
Actually,
they get up to speed. They're probably going what about 200, maybe 300 miles an hour.
it's about 185 to depending on the plane, obviously. But we'll say a Boeing 37 maybe,
Right,
probably
but it
just over 200 miles an hour. And yeah, it looks like 200 miles an hour when you're sitting inside of we'll say when you're inside the what do you call it,
the
where the
cockpit. I
baggage
mean,
and all that shit is.
oh, when you're in the fuselage. Okay, yeah,
Yeah, I could tell you that
okay,
because I also
yeah,
lived right under the flight path of a plane. So
right.
when they
That
fly
I
over and they land and they do all that stuff, you can tell how fast they are. Maybe you haven't observed it enough to see it, but I can tell.
No, I mean when I see a plane take off, and I know it's probably going 200 or 300 miles an hour. Well, it's probably starting at 200 and accelerating as it goes up. It doesn't seem
Well,
like it's going that fast. But if I go
well,
to a NASCAR race and I sit down and I'm in the stadium and I see that car go
you're
by at
much
200
closer.
miles an hour,
You're
yeah, I'm
sitting a lot
much
closer.
closer. It's much closer, so I can tell it's going faster. But the further away, it seems like it's going slower. That's the same effect that you're seeing on the video.
But
That
see,
that
okay,
that
I get
shuttle
it.
is
I get it.
probably the shuttle is probably further back. That's why it looks like it's moving slower. The other image you've seen, the shuttle was probably closer, and that's why it seems like it's going faster. That's that observation that you're seeing.
Actually, the observation that I saw was from the ISS, which is obviously further away than that because the satellites are just above it, or not above it, but yeah, just above it. So that would mean that yeah, I may see it faster, but not to that slow. At the same time, the same exact way that you're saying you should see something far away, it's slower. Well, the objects still move at that speed. So if it was smaller, it would still move at that same speed or at the same slow that you're seeing. So do you understand what I'm saying? Like,
Well, no,
okay, so the
yeah, I'm
whether
pointing out
that's
the
a
difference in the, yeah,
whether
I'm
that's
pointing out
a
the difference in the observations. That the
okay,
observation from
but
what
there's
we see, it would seem faster, it would seem slower.
okay, but they're still moving at the same speed. So that means regardless of how far they are and how far you observe them to be going, they still travel at the same amount. And so whether regardless, you would still see a difference in speed. You would see a difference in relation to it. If a spaceship is traveling away from the Earth in that direction at 17,000 miles an hour, and the Earth is going 1,000 in the opposite direction, you would see the difference in speed. The Earth barely looked like it was moving. And I know the Earth's so big that you don't see it spinning that fast, but would notice a space shuttle going 17,000 miles an hour. Because I also have video where a guy's playing with a little camera like he's just sitting down on the ground, and at 17,000 miles an hour, it doesn't work that way.
And what are you basing that observation off of?
Off the video that NASA's feed, yeah, I can show it to you.
Well, can you show me another video of something moving at 17,000 miles per hour?
Probably not. I can show you rocket feeds and stuff that they have.
Okay, so there's no way for you to compare that speed with something else going that
Okay,
fast.
I can show you a jet doing a 2,000 plus, and I can from with the stratosphere, and when the camera pans down, you just see different path.
Yeah, you
So on
broke up
times
there.
that it's going to be a little more.
I'm sorry, you broke up. I didn't I didn't get what you just said. I'm sorry.
So say like the B2, or we'll use the
Mhm.
Concorde. I think the Concorde was what did if I remember correctly, it was 22, 22.
Uh-huh.
No, we'll use the B2, whatever. Um, the Blackbird that did 2,200, and at stratosphere height, when they show cameras panning on the Earth, you see the Earth zipping by it, and that's
But
at
you're,
22.
but you're
At
much closer.
2,200,
But you're much
okay,
closer
at 20,
to the Earth.
yeah, but there's still 7 times that you would still think you'd be different. Now, my
Well,
depiction of it isn't going to be much different because I can tell that it's not doing what it says it's doing. You said it was moving with the Earth, but it's not. It wasn't moving with the Earth. Doesn't even make sense.
it's in orbit. Everything kind of still rotates with the, with the Earth. You think it has its own trajectory?
Wait, how does it rotate with the Earth? No, they're not inside the atmosphere. You do understand to have zero gravity, they have to be outside of the Earth's atmosphere, right?
Yes, I understand that they're in
Okay, so
orbit.
therefore, they're not. Don't tell me that they're still in orbit or still in the atmosphere. You told me that they're still in its orbit. They're not.
Right.
They
Well,
have to actually leave the orbit. And how fast do they have to be? 17,000 miles an hour to leave Earth's orbit.
right. Yeah, I misspoke. They are in low Earth orbit and they are still rotating with the Earth because we know that the satellites are in geostationary orbit and they don't move from their position.
Yes, they do. If they didn't, they wouldn't show trackers of them. Or go to a satellite tracker. They show them moving. They actually say that if you watch the ISS, when they say they're going by it, you see how it zips past it. Like you're not even making sense about it moving with the Earth. It doesn't. It has nothing to do with Earth's rotation. They have to go so fast to get out of the Earth's rotation.
Shawn, it's in the name geostationary orbit. They don't move. Stationary.
Okay. Do you want me to go to their trackers? Because I can show you that they do move. Otherwise, if they didn't move, when they say satellites are, go to Red Riddick. I know he loves doing that. He just put out one with the ISS flying past the moon, right?
The ISS, I said satellites are in geostationary orbit. I didn't say the ISS is in a geostationary orbit. Stationary.
Okay. Well, I was giving you an example of something that's big enough to actually see. I can tell you right now, if you go to satellite tracking, you can see the satellites in their orbits. They are not stationary. NASA doesn't even say they're stationary. So how do you say they're stationary?
If they weren't stationary, then people's direct TV would go on and off because
Okay.
they're
Well,
moving.
let me explain this to you. That's why they run off towers. For one, because if anything was moving that fast, it wouldn't work. And plus, if it was that way, weather wouldn't work because when it was obviously on the dark side of the moon, it was obviously not be able to see what they were tracking. But in your model, they even say they are orbiting. And if I have to show it to you because you just won't believe me that they say it, I can show you because they say that, not me. They do.
What are orbiting? You talking about the satellites?
Sat-
They say that the satellites are in geostation. Where'd it go? Oh, he dropped out.
Yep.
I mean, if it says stationary in the name, I thought that would be clear.
my
Um,
my bad.
it's
Actually,
fine.
I was trying to go to the next tab and I actually hit the wrong one.
Okay, so trackers on the satellites, the ISS and whatnot.
Yes.
Yeah, in the video I was showing, the astronauts went to the satellite. The satellite didn't come to them; they went to the satellite.
Okay,
It
that's
was
fine.
in the same. It was in the same place that they left it.
Okay, well, I'm gonna pull up one right now and show you that it does not. Oh, okay, well,
Now, you know there are satellites that they do move, though, right?
say again.
Is that you know there are satellites that they move, right? There's satellites that can be moved.
Moved how? They all, every single one orbits. Every single one has a rotation and basically has to move.
No, no, some of them are in geostationary orbit. Well, most of them are in geostationary orbit. They normally don't try to move satellites because, like you said, there's a lot of debris up there, so they don't
Oh,
normally
of
try to
course, there's
move
a lot
them.
of. I understand that. Now, how do you track them then if it is stationary? So that means you would only ever see them every blue moon. Plus, if they were stationary, that means when you're watching a football game and you turn away from it, there's no more TV halfway or half the time on parts of the Earth, right?
Well, if you have satellite TV, yes, but they're
Okay, so you're
stationary,
telling
so
me that my mom has satellite TV. She only gets satellite TV for half a day.
no, that's what I'm telling you. They're stationary. That they all that when you take um your your satellite dish and you point it up there, that satellite is going to stay in the same place and rotate with the Earth. It's not going to move.
Hmm, okay.
The Earth is moving. That's no problem. But the satellite is going to stay exactly in the same spot and move with it. Well, not
Okay.
move with it, but
I'll,
it's in the
I'll
same spot. And as the Earth moves, it kind of rotates with it. But it's in geostationary orbit. It's not moving from that position.
all right. I'm screen sharing it now. Um, just one of, and you can see obviously the path, right? Is that how the Earth rotates like that? As that red line is, that's how it rotates.
I, it's super small. I can't see that.
I mean,
Good Lord, that's
I can
little.
zoom it in. Yeah, but I didn't make the website. But this one, I mean, I can see it. I can see that red. Can you see the red line? I'm not sure.
Yeah, I could. Yeah, I can see the red line. Yeah.
Okay, that red line is a path that it takes. So you're telling
Mm-hmm.
me the Earth runs this path? Because I'm
Oh,
showing you right now. Like, hang on, I'm way too far in.
yeah. See, this is a weather satellite, and it does move. It's
Okay,
not
this one
this.
moves.
Yeah, it's not. It wasn't placed in geostationary orbit. It's a weather satellite, and they move it to where they need it.
Okay, okay. How about this one? Because I'm just gonna go ahead and randomly pick through the list that they give me.
Well, if it's a tracking site, they're telling you that they can track where they are, and usually these are going to be.
So this one has a big dip. I'm pretty sure there's not a big wobble in the rotation right around here, right? So you can see it moving too. So that one does move too, right? Go to the
Well,
next
yeah. I
next
mean,
one.
you're on a satellite tracker, so obviously these move.
Okay, well, you're telling me that they don't. They're all geostationary because that's where they sit. Well,
I didn't
I
say
can
they
show
were
you.
all geo. I didn't
I'm
say they
showing
were
you.
all.
No, you
I
did. You said
said
they're
most.
in. They said they're in
I said
stationary geo orbit or whatever.
I said most satellites are in geostationary orbit, but some of them do move.
Okay, now you're saying
Not
something.
all of them.
Okay, okay.
Well, I said that
So I'm
earlier. Because when you told me, I thought about it. But yes, some of them do move, like weather satellites. They obviously can move those to where they need them.
okay.
They're
Yes.
not pointed in the same spot.
Oh, of course not. I mean, I showed you a picture where they weren't. But I'm looking. I mean, you say I'm on a tracking one, so that's how it is. Well, I can tell you. I mean, I'm looking through the one that mostly tracked. So you would think that's how it works.
Well, no, because do you think that lists all the satellites?
All the satellites NASA puts up there, yeah. Here's the top 50.
Show me
So
what the
that's the
direct.
top.
Show me a direct TV satellite on there.
Okay, what's the name of a DirecTV satellite? Give me the name. I'll find. It says find a satellite. What's the name of it?
Oh, let me find that out for you. Um, hope it doesn't try to sell me satellite. I do not need. Yes, hopefully it don't try to sell me cable television.
Okay, well these are all TV satellites right here. I'm sorry, the first 25. Where's the? Can I go more? Okay, here's 85 matches for when I typed in TV. Here's DirecTV right here.
Okay.
DirecTV. See, track DirecTV 3.
And there's no red lines.
Yeah, well, there's a red line there, and it's tracking it. So every period it goes.
Wait, where's the red line?
Hang on. Very large. Trying to see the stats on it.
Shit, my bad. I apologize. I thought it was already presenting you. Apparently not. Gary, are you watching?
Yeah, I'm watching. Let me get it back up there.
Yeah, this one seems to be moving in a very funny pattern. I don't know what. I didn't know they did that, but that's the line it's giving me.
Hmm.
So it does
Yeah,
move
it
in
does.
weird squiggly lines. That's
I guess I don't know. I've never actually seen that.
it says. Where is it?
Mustang
And
just.
it says. It even says what? It says
I
it's
guess it
declined.
stays in. Yeah, I guess it
Go ahead. I'm
stays
sorry.
in a specific area, but I guess there is a slight bit of movement. I don't know because it's not really moving from that area. It's not like tracking across
Well,
the sky like the other ones.
I don't know why it doesn't show the same track. That seems like an even more weird of a tracking to be able to do squiggly lines.
Well, I guess I need to brush up on geostationary orbit because I don't know why it looks like. I don't even know what those squiggly lines are for, but okay.
You said DirecTV. I found a DirecTV one.
Right, but it's not like. I mean, I guess it's moving. Yeah. Okay, so you're right. It does move. It doesn't leave the general area where it is, but it looks like it does move up and down and back and forth.
That's just the same one.
Yeah, it's still going to be in the same spot.
Well, I mean, I guess I'll sit here willingly wait, and I'll let you know. But it seems like it moves in different directions to me.
Uh, yeah, it looks like it stays in the same area, and it may, I guess, traverse slightly. 'Cause you don't see the
So,
red
like,
tracking lines like you see the ones that actually move that aren't in
well,
geostationary orbit.
well, I don't know why. I'm seeing one that still moves. I don't believe it does squiggly lines all day long.
Yeah. Um,
I mean, even you said that seems like a weird pattern to be making up for a satellite, especially if that satellite is so high up, it's supposed to get that whole area anyway.
are they saying it changes in elevation? Is that what that is? Is
Yeah,
that why
it's
it's
actually
yellow?
it says +01 right now,
Hmm.
and it's moving at 1.9 miles a second. So you can see that, right?
Yeah. I wonder if the yellow lines mean that it's
So
elevation. It goes up and down. That is weird.
so
But
so at 1.9 miles a second, it's moving pretty good.
yeah, but it's moving with the Earth. I mean, you're not going to notice a
No,
difference.
Earth moves much faster than that.
It's moving with the Earth. It's not.
So
It's
you're
not.
telling me the Earth moves at Earth moves them at 1.9 miles a second.
No, moving with the Earth doesn't mean it's moving the exact same speed. You do understand that, right?
Then it's not moving with the Earth.
Yeah, it is. It's moving the same direction. That's what that means.
Okay. If when someone says I'm moving with the car, you're obviously with the car. Not the car's doing 125 miles an hour faster than you. Am I wrong?
Right. Obviously, I'm not going to be able to go 120 miles an hour with a
I'm just
car.
saying in theory as an explanation for comparing to what you're saying, because the Earth moves much faster at 1.9 miles a second, right?
Well, think of it like this: say you were with the say a merry-go-round with horses, and it's spinning in a circle, and you walk around in a circle with the merry-go-round. Doesn't mean you have to be going the same speed, but as long as you're moving in the same direction, you're moving with the merry-go-round.
Okay, I understand that, but what I'm telling you is that then that should be not, and then it does not stay there. That means that satellite is either going to be obviously behind the Earth's rotation, which means it's going to travel that whole area. It's not going to stay in one spot.
No, it's going to stay in that one spot where it is. It will always be right there.
Okay, so if the Earth is rotating faster than it's moving, how does it stay right there?
Because it's in geostationary orbit. I'm not sure exactly how that works, where it stays in that exact same spot and moves with the Earth, but that's how it works.
Okay,
I don't
so
know. I
you're
don't know the
telling me
complete
that
details.
logical math is thrown out the window because you say that satellite stays right where it's at.
I don't know the math, so I can't tell you if it's logical or not.
Okay, well we can look it up. We know that that satellite is moving at 1.9 miles a second. We can see that, right?
Well, are there other variables that you probably don't know?
Like what? It's telling me how fast it goes. Now we can go look and see how fast the Earth is moving. I don't think it makes any damn sense. You know what would make sense to me? If that satellite stayed right there because the Earth isn't rotating.
When it's saying the Earth is moving at the speed you're talking about, what's the range of
I
that?
don't
Because
know. No,
this
wait,
one
wait,
here,
wait. I'm telling you the speed at which you think the Earth is rotating.
well, no, I mean I'm looking at the speed that it says here, and it says kilometers per second and meters per second. So the speed you're talking about, is that in kilometers or meters?
That's in miles a second. Kilometers, it is going 3.06.
Okay, and that's its relative speed, or
Yes, I'm assuming so. If that's what they're saying, it's in water, so it's not nautical miles. You know, it's. Do you want like a crow's mile or something? I don't understand what you're asking me. It says how
well,
fast it's going.
yeah. Once again, I'm not an expert in this, so I don't know.
So
That's the
okay,
only
then
answer I can give you.
okay. I prefer the I don't know answers than you're telling me what it does and what it doesn't do when the obvious is sitting in front of both of us.
Yeah, I'm pretty sure you're not an expert either, so you don't know.
No, I'm not an expert, but I'm obviously knowledgeable enough to go 1.9 seconds and miles per second is not the same as the Earth, what they say, because they say it, speed going around. There's a difference,
Probably
obviously.
the best thing I can tell you is there's probably factors that you're not aware of.
Okay, well, I mean, we can go to NASA because I mean, here's the thing. I'm telling you, I can tell that that doesn't match because I know 1.9 miles a second is slower than the Earth's 1,000 miles an hour, which is all the numbers that NASA gives. They
Right,
don't
there's
say
probably
any variables, so I don't see why I would have to. Matter of fact, I would think that 1.9 miles a second in space would be easier. There's no friction. There's nothing to slow it down.
yeah, but I'm not an
It's like
expert in.
perfect.
I'm not an
Okay, then
expert
why are
in
we? Okay,
satellites. So once again, I can only tell you that they say
you don't know.
that satellite is in geostationary orbit. It will stay there and it will move with the Earth.
No,
I
okay,
don't
no,
know
you cannot tell
exactly
me. You
how.
can't say that. You cannot say that because just the logical numbers say that's not true. And you've already told
Actually,
me, you've already said
actually,
you don't know enough about satellites to tell me what that satellite is doing. Am I wrong?
I don't know enough about satellite to tell you all the variables. No.
Okay, so therefore you cannot tell me that that satellite is stationary because logically, and I know you're not willing to admit it because then it would go against what you're saying, that 1.9 miles a second is still slower than the rotation of the Earth, which would mean that satellite cannot be stationary above where it's at right now.
So you're telling me that you know all the variables to say that that satellite
Okay,
is not
so
stationary?
let me get straight. So is 100 miles an hour different on
No,
roads than it is on a plane?
no, I'm asking you. Are you
No,
saying you
I'm
know
asking you
all?
now.
Hold on,
Is
I'm
100
asking
miles an
you.
hour on a car different than 100 miles an hour on a plane? Because there are different variables.
Okay, I'm asking
Wait,
you if
or
you know.
100 miles an hour on the water. Is there any difference?
I'm asking you if you know all the variables for calculating if that satellite is in geostationary orbit. Do you know all the variables?
Yes,
Is
I
that
would
the
know the
claim?
variables meaning that they
No,
would have
do
to
you?
match. They would have to match the same speed as the Earth's rotation to be stationary,
How do you know this?
or how because there's this logic. It's just pure logic tells me that. Now you tell me what
Based,
logically says different.
based on, okay, tell me the variables that say that it can't be in geostationary orbit. What are the variables?
It would have to coincide with the. But you don't want to know what logically it says to me? It says that maybe, just maybe, that satellite is maybe a geostationary because there's no rotation to have to counteract.
What?
But maybe, see how it goes down, up, down, up. Maybe it travels that line at 1.9 because it has to be moving. But maybe that's why it stays over that line because it is stationary and so is the Earth.
Yeah, I don't think you know all the variables. I think you know all the variables, though. I
Okay,
don't
why
think
don't
you
you
do.
explain to me what variables you were discussing? What does have variables that you can tell me about? Because you're bringing
Once
variables into
again,
it, like you know.
yeah, because I don't know all the variables, and I'm asking you, do you
Okay,
know all the
so
variables? Because I don't.
what would be the variables of a car driving 100 miles an hour?
I don't see how that's relevant in this situation.
Because I want to make sure you understand what the definition of the variables are in this situation.
What situation? What are you
Now,
talking about?
I just think you're asking me, do I know the variables of the speed of the satellite based on the fact that you skills hinder me from being able to say I'm right. So I want to know that
You
you understand what the variables are of that satellite going 1.9 miles a second. So that would mean you would understand what the variables are of a car doing 100 miles an hour on a road.
I don't see how that. I don't see how you can compare the two because you're talking about something driving across asphalt and then something rotating in an orbit. I
Okay,
think there's
then tell me the variables of a car on it. Because no matter what you're asking me means the same for all speeds. There's a variable that means. Go
no,
ahead.
no, no. You can't use
Okay,
that.
so let me
Hold
explain.
on.
Let me explain to you
You
then.
can't
Let me
use
explain
that
to
for.
you. So for a car, it has to overcome the friction of the tires on the road. In a boat, it has to overcome the friction in the force of waves or current. Those are variables. Now you tell me what the variables are for the satellite, and don't talk to me like I don't know what I'm talking about because I do. I just wanted to see if you. So just so you understand, there are no variables because there's no wind and there's no air for that satellite to have to cruise through. So that is doing the most consistent 1.9 miles a second than anything could on Earth.
Are you saying those are the
Now, go
only?
ahead, Gary.
I've already said I didn't know what the variables are. Are you saying that's
Yes, you
the?
know what?
Are you
As
are
far as
you
whether or
claiming
not
that
it
that's the only variables that are necessary? Is whether or not it has wind and
smashing
air
into
interaction?
smashing into other satellites. That would be the only other variable.
Are you sure?
Yeah, I'm more sure than you know what variables are.
I don't know what the variables are. I'm asking you what
No, I'm just
variables
saying
do
in
you think?
general. Like I just explained to you the variables of driving 100 miles an hour on a road versus on a boat.
Well, I can
Question
tell
which
you
you
those.
asked.
Actually, I can tell you those aren't the only variables. If you think that's the only
Well, you're right.
variable.
You're right. You're probably right. But at least I gave you an example of. Now I told you what I think the possible variables could be for that satellite. Now you tell me.
Well, wait a minute. If I'm using your example of boats and cars on the road, then you're missing multiple variables. So I don't know how you're
I am,
coming up.
and I just said you're probably right, but at least I gave you a couple of examples. At least I did.
Right, right. But
So
if I use the information you gave me about the car is the only variables, then I would be wrong. I would be
okay,
way wrong.
wind resistance, wind resistance, friction. Those are the only variable. I mean, other cars in front of you, um, the law of speed limit, uh, the person's willingness. I mean, those are variables. Those are pretty much all the variables for a car going 100 miles an hour. Is that enough?
Well, no. What about the efficiency of the engine? The
Well, if your car can't do it, your car can't do it. And that would be have
no.
to do with resistance, the friction. All those things matter
No,
too. Oh, you're
no.
right. I'm sorry. You're 100% right. It has to have 4 tires. They have to have air in the tires. You have to have gas in your car. You had to have woken up that morning. You had to, you had to eat breakfast probably. Maybe take a shower, wash your hands. Do you need those variables too,
No,
or do you
the
need the
variables.
basic?
Actually, the
Those are
variables I would
variables.
need. Hold on. The variables I would need to determine how fast your car can drive is once again the type of fuel you use.
Okay, so did you ask me or did I say this are the exact variables for it, or did I say here are a couple of examples? Because examples are sufficient enough to say that I know what variables are. So when you ask me what are the variables of that, I gave you at least the one or two I could think of.
Right, but I don't know all the variables for the satellite, so I couldn't tell you. I couldn't give you an accurate answer.
So
And you're
then
telling me you know
okay.
all the variables for the satellite to be in geostationary orbit, but you
Oh,
haven't
really?
given me
Because
them
I'm
all.
happy this is on recording because I sure as hell not say I know all. I just said at least a couple that I could think of.
No, you said that the
I,
only thing
I could
you were
think
very
of.
clear that the only thing that the
Okay,
satellite would have
okay.
is
Promise me something, Gary. When we're done with
crashing
this
into other
and it's on
satellites.
to recording, that you will apologize for saying that I said all because I did say I can think of. Will you at least do that? If I did say that, will you at least do that?
You said the only thing would be the satellite crashing into other satellites because of the debris, because there's no wind resistance or atmosphere, and that would be all it would need. It should have the maximum amount of speed,
I
unless I guess it crashes into other satellites.
Okay. So
Isn't that
did I say that, or did I say I know all of the variables? Because I said what I thought I could think of variables, and it's on recording. So when it does get posted, and you do understand that I didn't say I know all. Will you apologize?
yeah? I didn't say you knew all the variables. I'm saying that you said
Okay.
you.
Now I want you to apologize when when you do in fact say that you did say I said all. See, you did this with me being a surveyor. You're a liar. You said I was a liar. You're not a surveyor. Those were your words.
No, I didn't say you weren't a surveyor. I said he must be lying. That doesn't mean that I say you're not a surveyor.
Um, I mean, we can, in the formality of this debate, and you can have your moderator play that wonderful video you just decided to post to him.
Yeah, you're breaking up.
Fine. You can have a moderator play the video you posted in that back. At about 2 hours and 46 seconds is when it all happened.
When all what happened?
When you called me a liar. When you said you're lying, you're not a surveyor.
Alrighty, guys. Well, it's been a fun debate for sure, but I'm gonna end it here. But
This is usually how flat Earth globe debates end, anyway.
Okay.
yeah. Thanks both of you for being part of this.
No problem.
Yeah, okay.
Shawn,
I do appreciate you having me.